Hello and welcome to the course Advanced Computer Network. This is the fourth lecture of Module 5, and in this lecture we are going to discuss about security association, and this is the part 1 of security association because security association will take 2 classes to complete. So let's begin. If you remember, we have already covered 2 modes of IP security, that will be your transport mode and the tunnel mode, and 2 versions of protocol, that is your authentication header and encapsulating security payload. Now we should know about the security association, which will be talked today. So what do you mean by security association? As we have already given the definition that whenever in a network layer the connectionless service is established, because IP is itself connectionless protocol. So to apply the security on a connectionless service is difficult. That's why we have to convert the connectionless service to a connection oriented service and apply the security measures. So that's why the security association is needed. Now let's see how it is done. Okay, so before I'll discuss about security association, I like to highlight the point that we have discussed in the last 2 classes, which will help us understanding the security association in a proper manner. So let's begin with this scenario 1. In this scenario 1, you can see this is the sender side where 2 people are involved on this sender side, and in the receiver side there are 2 people involved. Out of this, the S.node is the sender and R.node is the receiver. So S node has been connected to Mr. Router 1 and R node is connected to Mr. Router 2. And in between them, you can see there are several routers connected in between the path. So this is the path established between the sender side to the receiver side to transfer the packets. And we know that in a networking term, whoever takes the packet and deliver to the next hop, those are called routers. So these peoples over here you see in this picture, all are known as one router. Now we have discussed 2 mode of operations. One is called transport mode and another one is called tunnel mode. If you remember, in the transport mode, what we have done, suppose S node want to send a packet. Let's say he want to write a message to R node, then he will type the message on a paper and send it to your Mr. Router 1. Now you assume that this Mr. Router 1 can be a actual router in your computer networking term or whenever you are using networking, and it may be act as a firewall for your S.node or source node. And similarly, this also act as a router for R node, or maybe it is a firewall for R node. Fine. So when you type the message and send it to Mr. Router 1, so what he will do, if he is particularly applying the IP security on this message, so he put this message inside a envelope. So now the envelope contains the message you have typed, right? Along with putting that envelope, he will attach the IP header, or which is called the source address and the destination address. Generally, in case of a transport mode, the payload. So what is the payload over here? The message S node want to send to R node. So that will be encapsulated, or that will be put inside the packet. That means the confidentiality of the message will be preserved in case of a transport mode. Source address and destination address will be given, and it will be flow through the network. It will travel through many other nodes. For this analogy, it may be travel through different persons. The persons may able to know the source address and the destination address, but these persons are not able to know about source address and destination, but these peoples will not able to know what the message contain. Means the confidentiality of the message is preserved. right? After this packet arrived at Mr. Router 2, he will see the destination address and transfer it to R node, who is the designated user or designated means that is the destination, who will take the packet and open the packet to read the message. This is what happened in case of your transport mode. But another the security feature has been given that we'll discuss in the scenario 2. Let's say the sender node, the S node, want to send a packet to R node. In case of a tunnel mode, what we are doing, generally, let's say S node will write the message and given it to your Mr. Router 1, which is nothing but a router or a firewall. If the security IP security is applied on this, then what he will do, he will apply the that means it will put the message inside an envelope. After putting the envelope, again he will add the source address and destination address, which will be S node and your R node. Again he put everything inside a outer message or outer envelope, which contains the source address as your Mr. R1, that is the so sender address will be Mr. R1 and the destination address will be Mr. R2, right? That is your router 2. By putting this, he will send this message to the network or flow this message to the network. Now, even if this message will be seen by these peoples in the path, these people will not able to know who is the actual sender and who is the actual receiver. But he is able to know that some router is sending the packet to some other router. Okay, that helps in providing the authentication, integrity, confidentiality, everything will be preserved by doing this method. Okay, so this is called actually the tunnel mode. So in tunnel mode, the actual payload along with the source address and destination address will be encapsulated, and that means that will be put inside a message envelope, and it cannot be seen by the routers that are transferring that packet to the receiver side, right? So this is the scenario 2. In the similar manner, how these are done, how this tunnel mode or your transport mode has been done, we have discussed two protocols, that is your AH protocol, that is your authentication header protocol, who will be responsible for authentication and integrity, who will provide the authentication and integrity but not the privacy or confidentiality. But if you think about the encapsulating security payload, or that is your ESP, he will provide all the features that will be your authentication, integrity and confidentiality. So all the three features has been provided by your ESP. So either of the protocol can be used in your transport mode or your tunnel mode. So I'll still recommend, before you watch this video, entire video, you should go and watch the previous two video, which will be easier to understand, means which will help you understand this video properly. So let's begin the concept of security association. So a security association means, that is called, IP security requires a logical relationship called a security association between two hosts. Okay, so this is nothing but that is a logical relation provided between two hosts, those who want to communicate. Here you can assume two hosts are S.node and R.node. So if those two persons want to communicate with each other, then they need a security association which shows a logical relationship. Okay, again, security association, as we have already talked, change the connectionless service provided by IP to a connection oriented service upon which we can apply security. So this part I have already talked about in every lecture of your IP security class. Now let us understand the idea of security association with a figure over here. You can see this is the S.node and this is R.node. They want to communicate with each other with a message. So we can say a security association is a contract between two parties. It creates a secure channel between them. So they want to connect a secure channel between the S node and the R node. Now let us assume that s.node needs a unidirectional communication. That means he only send the message to R node, but R node may not send any message to S node. So if it is a unidirectional communication, then they want, and another concept you should think about here, S node want a unidirectional communication, as well as he want only the confidentiality to be preserved. So confidentiality means, what do you mean by confidentiality in a message? Whenever you are sending a message to other party, what do you mean by confidentiality? So confidentiality means it assures that private or confidential information is not made available or disclosed to unauthorized individual. So if this is the case, means it is a unidirectional communication, and as well as it wants a confidential message, then they can get a shared key. So he will share a key with your R node, and he will encrypt the message. Okay, encrypt the message with the key, and R node will decrypt that message using that key which was used by your S node. That is for unidirectional communication. But it is not always possible that in a network we will only perform unidirectional communication. So there will be a bidirectional communication always. So whenever there is a bidirectional communications, that means if a peer relationship is needed, that is your two-way secure exchange, then two security associations are required. So previously I talked about one security association, that is your SA. So that one security association needs only a key, but whenever you want to make a peer relationship two-way security association, then you need two security associations for that. And what are they? That are called one outbound SA, and second one is called one inbound SA. So it contains your outbound security association, and it contains inbound security association. So what are they? Each of them stores the value. So outbound SA or inbound SA, each of them stores the value of key in one variable and the name of the encoding or decoding algorithm in another. So two things has been needed, one key and another one is algorithm. So we'll store it. S node uses the algorithm to and the key. So S node will use this both to encrypt a message, and when the message has arrived to R node, the R node uses the algorithm and the key to decrypt the message. This is how the two-way communication possible in a security association. Right? Now, the security association can be more involved if two parties need message integrity and authenticity. That means currently we are talking about only the confidentiality. That means we will assure that the message is confidential or private message, and it should not be disclosed to unauthorized persons. But if I want to implement the same communication by applying this integrity as well as authentication, then the communication will be slightly more complicated. Each association needs other data such as algorithm for message integrity, the key, and other parameters. So that means multiple things will be now required to make the communication with three facility. It means all the facility of security should be preserved. To preserve that security features, what are the security features we have to preserve? One is called confidentiality, integrity, and authentication. So that will be slightly more complicated. Now, a security association is uniquely identified by three parameters. So how the means if you think about that S node and R node, how the security association is identified. So there are three parameters which define the association between both the party. So one is called your security parameter index. If you remember in the class of your two protocol, that is your AH and ESP, there was a field named as security parameter index. We have already talked about this in the previous classes, but still that we need to explain this one over here too. So what is that security parameter index? a 32-bit unsigned integer assigned to this SA, whenever, if this is your S dot node and this is your R dot node, and in between them there is a association, security association, or a logical connection has been established, then a 32-bit unsigned integer is assigned to this SA and having a local significance only. So it is having the local significance between both the party. The SPI is carried in AH and ESP header, as I have already talked you. I have already told you that AH also contains this field and ESP also contains the same field, security parameter index, to enable the receiving system to select a SA under which a received packet will be processed. So this will be transferred through your AH or ESP whenever you are transferring the data from S node to R node, right? Now the second identifier to identify the security association is your destination address. This is the address of the destination endpoint of the SA, which may be an end user system or a network system such as a firewall or a router. As I have already told you that whenever S node wants to send the data to R node, he may associate it with a router in between. Either it may be a router or it may be a firewall. S node will send the packet to the router, then router will give that packet to the other router of the destination side, and this router will transfer this data to your R node, right? So this destination address specify either the address of this router or the address of this R node. So when it will be the address of this router or the that is your firewall, when we are applying the tunnel mode. In tunnel mode, what will happen? The entire packet along with your IP header has been encapsulated. Okay, so that time the address will be this one, and if it is not encapsulated, only the payload has been encapsulated, then the destination address will be R.node, node's address. Okay. Then last one, protocol. So which protocol is actually associated with your security association? Means whenever the association will be established, which protocol is actually we are using, either H or ESP. So whatever we have used, accordingly the decryption algorithm must be taken care of, or means the decryption will be done at the R node side. Fine. This is all about your security association. There are something more to discuss about security association. Those are, think about a scenario. So what scenario we are talking about? Let's say S node want to send a message to many people and R node needs to receive message from many people. So as we have already talked about, we are talking about only one user connected to the other user. But if assume that if there are multiple users, R want to send messages to multiple peoples and R want to receive the message from multiple people, and S node is wanting to send message to multiple peoples. That means many to many communication. Whenever there is a many to many communication, then many to many security association has to be done, means logical link has to be done. Suppose these are the sender and receivers. Maybe this sends the data to these nodes. Then these lines are showing the security associations. So for each security association, we are representing the data. Already these data has already been represented with these parameters. So we need to represent all the parameters. Similarly, if this is the man or this is the person who is receiving the data from many routers, so he need to represent everything from other sources. So in that case, each site needs to have both inbound and outbound SA to allow bidirectional communication. So as I have already talked, so every node needs to maintain the inbound and outbound SA. That means we need set of SA, that is called inbound SA and outbound SA. So to represent all these SA, it is not possible with a single row or single row of a table. It needs another database for that. So hence we need to store all these SA in a database, and that database is called your security association database. So now we will talk about your security association database. Okay, so let's go for discussion of security association database. So what is a security association database? It is a two-dimensional table, each row defining a single SA. Okay, so SA means the security association between two nodes. Normally there are two SADs, or that is your security association database, one inbound and one is outbound. When a host needs to send a packet that must carry a IP security header, the host needs to find the corresponding entry in the outbound SAD to find out the information for applying the security to the packet. So let us understand this. Suppose I'll go to that example only. So here, so he will maintain a inbound database, and it will represent a outbound. Sorry, it will represent outbound database. It will be represented in inbound database. So if he want to send, so might be S node is connected to other nodes too, right? So whenever S node is connected to other node, then when he want to send the data to a particular node, then what is the rule and regulation followed by these two party must be there in his table. It is like something like this. Let's say I am a person, I have many friends, okay, and I shared my secret to all different friends, means different secret to different friends. So I need to maintain a database that which particular friend of mine, and to whom I have shared which type of secret. Let's say this is a person 1. It has, let's say, secret 1, secret 2, secret 3, 3 secret story. Person 1 is friend of, let's say, person 2, person 3, person 4. Okay, let's say person 1 has shared the secret 1 to P1, and secret S3 to P3, and secret S2 to P4. Then he has to maintain that database. Otherwise, whenever there is a further communication, so S1 is associated with P2, S2 associated with P3, and S2 is associated with P4, and S3 is associated with P3. So he has to maintain that database. Then only when further communication will be done, or he want to send any message regarding your S1, then he has to search for the database that to whom he has tell the secret. Okay, so he has tell the secret to P2, that's why he will see the database and he will find that I have shared the secret 1 to P2, so the further communication about S1 must be sent to P2. So that is the case. So we have to maintain a database over here, so he also maintain a database. So according to this analogy, now you can easily understand this 2 point. When a host needs to send a packet that must carry a IPSec header, the host needs to find the corresponding entry in the outbound SAD to find out the information for applying the security to the packet. So what type of security I have to apply, that need to be found out by the SAD database. Similarly, when a host receives a packet that carries a IPSec header, the host needs to find its corresponding entry in the inbound SAD, because he has an inbound SAD which shows from whom he is receiving the messages, to find the information for checking the security of the packet. Okay, so this is how the things are being communicated using security association database. Further, some fields are maintained by security association database. So what are the entries that are maintained inside the security association database? Those are these fields. So what are the fields? Let me read it out loud. Security parameter index, which we have already talked. Security sequence number counter, sequence counter overflow, anti-replay window, AH information, ESP information, lifetime of this security association, IPSec protocol mode, then path MTU. Okay, so these are the different fields can be represented in your security association database. The detail of these fields are not out of scope, so hence we will not discuss these. Those who want to know the detail, they can follow this book, William Starling book, that is your Cryptography and Network Security Principle and Practices, 7th edition, chapter number 20. You can follow for that. But still, I can say you that most of the fields has already been discussed in your previous classes, and some of are new over here. Like security parameter index, you know, this is the field which came across your AH or ESP packet header, right? And if you think about your which one, AH information, ESP information, that is authentication header information, and this ESP protocol information, that has to be maintained over in the SAD. Similarly, if you think about MTU, what do you mean by MTU? The MTU means the maximum transmission unit. So what is maximum transmission? The maximum size of a packet that can be transmitted without fragmentation. Okay, so those kind of things that will be actually represented in your SAD. Another point, let me discuss which one, that may be the mode. So what is this mode represents IPSec protocol mode. So that will be either tunnel mode or transport mode. Okay, so these informations are maintained inside your SAD database or your security association database. So those who want to know more, you can go to this book. But security association also need another database. So what is that? That will be discussed in the next class. So thanks for listening. Bye bye.